I think I'm kind of a strange engineer in a lot of ways. For some reason, a lot of the engineering happens on kind of an intuitive level that I'm not even fully aware of. If I have a problem that's really hard, I'll go lay down on my bed and close my eyes and just like focus on it in my head and just start working on it. The iterations are just flying around up there, and pretty soon things start to fall into place. And then pretty soon you realize that you have something. And then, you can go back to the computer and draw it up. I really don't know how to describe it. It just shows up in there, and if I feel good about it, it's going to work. And if I don't, I keep thinking about it until I feel good about it.
He's an absolute super genius. He's an engineer that is also maybe the best machinist in the shop, right? So he can take what he draws up and then prints and whatnot, and then he can go make it and prototype it and then come back and re-engineer it. And it's not just the machining of the parts, it's actually the strategy behind all the fixturing, the machining, the entire strategy about, okay, that's nice that we can make one, but can you make 10,000? Like, he's the 10,000 guy. Yeah, he's brilliant.
When it comes to initial concepts for fixturing, all that mostly just sort of floats around in my head. Really, I'll be doing anything. It's always kind of churning in my head. I mean, I've like woken up in the middle of the night and an idea was just there, like a problem was just solved. Like, I don't know if I solved that problem or like it got kind of solved on its own somehow. Like I can't say that's the best way to do engineering, but that's kind of the way that it works for me. So, once you've got a concept that you're happy with, then you can go put it into CAD and actually make it real. I'm Jacob Good. I'm a mechanical engineer here at Montana Knife Company, and I was the lead engineer on the Montana folding knife. We're out a ways away from things. Our backyard is kind of, if you look at the nothing corner of Idaho and you look at the nothing corner of Oregon and the nothing upper part of Nevada, we are kind of butted right up against a bunch of nothing, which is kind of nice. But it's an hour and a half to get groceries, and that has pros and cons. Sometimes it feels a bit isolated out here, but when I go up to Montana Knife Company and I walk around the shop and just see all these machines running day in and day out, and then see what that allows us to do as a team with that sort of a foundation, that's pretty special. I like that feeling. It is tough to not be able to be there all the time. Because generally when I am there, I learn a lot just watching our processes run. Because there are always things that come up that you don't think about. But then, you like watch a process for one cycle and I'm like, well, yeah, there it is right there. We need to do this or do that. It's kind of tough. I don't know if I'd recommend it. The fixturing actually, in a lot of ways, came before the knife. At least the foundation of how we do our fixtures at MKC and how we machine, that all came before we had a folder, but it was all created with the folder in mind. We knew we needed to be able to machine G10 as soon as possible, but we also knew we wanted to have the ability to machine folder parts as soon as we had a folder ready to go. And so we set these machines up with this whole quick change fixture system on a 4th axis trunnion. So we had access to multiple sides of the part, a part tray on the machining table, spindle grippers, the machine can now load itself. All that was done with the intent of making G10 handles right now and then folder parts down the line. When you buy a CNC machine, you have this machine that can make all these different moves in space, but it all kind of comes down to this blank table, which is like a blank slate. And then you get to figure out how to accurately hold your part in this machine on this blank table. So yeah, in its most basic form, the fixture is the way that the part gets held in the machine. It has to get held strong enough that the machining forces don't move the part, and it has to be held accurately enough that you can load one part after another and have all the features end up in the same spot. And that's where fixturing starts to get complicated. The fixture basically has to go from this fully constrained, really accurate state to this completely unconstrained, easy to remove state. When you get into higher volume production, your parts will often come into the CNC machine a lot closer to net shape. So instead of having a nice block of steel, you'll have a laser cut blank that looks kind of like a knife blade. But because it looks kind of like a knife blade, there are no parallel edges. Nothing's really straight. You really don't have anything that's easy to hang on to. And so you have to sort of form your fixturing around this abstract part and hold it in just the right way that all your machine features are put in right where they need to be. And the mechanics behind that sometimes get challenging based on the parts. Yeah, so this is a slave cylinder piston that I developed for the KTM Husky gas dirt bikes. The stock Brembo stuff is really pretty good, but the Magura and the BrakeTech, they struggle. The Brembo is a forged housing. The Magura and the BrakeTech are cast, and that cast introduces a little bit of porosity into the bore, and I think that's where they have a lot of trouble with those O-rings lasting. So this is a much higher end O-ring. It's an O-ring that can actually handle brake fluid and engine oil. It's extremely expensive. It gets rid of the rubber diaphragm over the front that always likes to tear, and replaces it with just a really high-end O-ring. Yeah, I've been riding dirt bikes since I was about 5 or 6. Started just riding around the farm, and the love of riding dirt bikes just sort of grew and grew. For me, riding dirt bikes off-road is really just an escape from what I do the rest of the day, because most of my time spent engineering is spent just overthinking everything. You can't overthink on a dirt bike. Once you're moving, at speed and going over terrain that wants to hurt you, you have to make all your decisions instantly. Yeah, when I'm on a dirt bike, that sort of mode of overthinking gets turned off completely, and it's more of a primal sense of survival shows up, and it's a nice contrast from overthinking to just having to survive, I guess.
No, Jacob absolutely is a savant at like part design. He can create all of this in his head as just like a concept, like while he's eating lunch, and then go out and actually build all the CAD models and go out and make it on a machine, or he knows shops that can make these components. He can just like create this from nothing, and that's so hard to find. A lot of people that come into the shop, they look at this and they see overkill, really based on like the size of the company that we are and the number of parts that we're making right now. But we're not trying to build processes to make our jobs for today. We're trying to build processes for like 10 years. Like, we're still supporting the same process with these tools in 10 years. So already these have tens of thousands of cycles on them. I would imagine we start maintaining around 500,000 cycles. And hopefully one day we have millions of cycles.
I think it has surprised some of our employees that we've hired who have been in machine shops before. It's just so different than what you find in a smaller volume shop. And, we're not making the most volume right now, but we are absolutely setting ourselves up for volume. The moment we implemented those trunnions and that fixturing style to make our G10 handles, that's probably not exactly what we needed at that time, but it's exactly what we need now. And that's why we did it 2 years ago. This plate here with these vices is the quick change portion. We attach an air line to this port right here. These big clamps release, and the fixture can be pulled off. A new one can be placed on, air taken away, and it's clamped solid and ready to go.
If I just hand you that knife and you just look at it, it doesn't look that difficult. I've caught myself in the last couple of weeks, like handing it to people and being like, guys, it's so much harder than it looks. Like, I want to tell them and show them like what I have been seeing Ian struggling with, and Mac and Devin and Dylan and Ken and Travis and Jacob and Ryan and Shelby. Like, everybody. Like, this is a team, and I didn't name half the other people. They're all huddled around this knife right now. And I think the consumer's going to look at it and go, that looks good, looks simple. And that's a good thing. That's how we want it to look, but it's much harder than it meets the eye.
You can learn so much by just examining like where things landed. So much is up in the air when we're prototyping, and then when we're developing the processes. It's really neat to see where it all landed after it's all said and done. The changes that we're making from R&D 1 to R&D 2 hopefully will not be noticeable from the customer's perspective. Once you start making parts, you are always going to be learning. That's really what RD1 to RD2 is going to be, is just a number of manufacturing improvements, some optimization here and there. Obviously, we are trying to make things quicker, but even more importantly, we're trying to make things better. We would never go quicker just to go quicker and have, ship a substandard part because of that. The goal is reliability, both in the process and in the product. So whatever we can do to make a more reliable process, that just rolls right into making a more reliable product. What we came up with here in the Montana is just a really nice, lightweight, everyday carry folder that anyone can put in their pocket and be happy with. We're just getting started, We're just getting started, and it's exciting that we have the ability to improve what we do, improve our craft every single day. And we do. There's definitely so much room for other designs and other mechanisms and just other knife shapes. The future right now is just wide open. We definitely have some ideas. We'll say that.